Yes, so Assalamu alaikum. Today we will be doing chemistry paper 2, May June 2023, 45 minutes, 40 marks. Bismillahirrahmanirrahim. Let's start. Okay, so question 1. Four physical changes of ethanol are listed: condensation, evaporation, freezing, boiling. In which changes do the particles move further apart? Okay, so in order to decide the movement of the particles, whether they are coming close to each other or moving apart, we have to first know the change of state which is taking place. So condensation is when gas turns to liquid, gas to liquid, water droplets are formed. Evaporation is when liquid goes to gas. Freezing is when liquid freezes, it becomes a solid. Boiling is when liquid goes from liquid to gas, when we boil water, for example. So the thing is, we have to know the arrangement of the particles in gases, liquids, and solids. In gases, they are very far apart. So when an object or when a substance goes from gas to liquid, it means it particles are coming close together to form a liquid. As for solids, the particles are tightly packed with a regular arrangement and they cannot move except for vibrations. As for liquid, they can move around a little bit. They touch each other at least. So they can slide over each other. So when ethanol condenses, it turns liquid. So the particles are in fact coming closer. So this is condensation is not right. Next is liquid to gas. So in liquid to gas, obviously the particles are moving further apart because in gases they are the furthest apart. So yes, second is correct. In freezing, the particles are going from liquid to solid. This means that they are coming closer together. Again, the same problem we had with condensation. So wrong. As for boiling, they go again from liquid to gas, same as evaporation, just that we have to provide heat in this, while evaporation occurs at room temperature. So we have statement 2 and 4 correct. Next question. An atom of element X contains 5 protons, 6 neutrons, and 5 electrons. Which statements about element X are correct? X has an atomic number of 6. Incorrect. If atomic number was 6, the number of protons would have been 6 also. Atomic number is number of protons. Next is has a nucleon number of 11. Correct. Because nucleon number is number of protons plus number of neutrons. So when these two add, we get a nucleon number. We have number of protons 5 and number of neutrons 6, totaling to 11. So this is correct. X is in group 2 of the periodic table. To decide the group, or as in statement 4, X is in the second period of the periodic table, we have to first know the number of electrons in its outer shell. So if it has 5 electrons, we have, which means 2 in the first shell, maximum number of electrons in the first shell is 2, and 3 in its second shell. So the number of electrons in its outer shell tell us the group number. So 3 electrons meaning group 3. So this is wrong. Fourth, X is in the second period of the periodic table. Period indicates number of shells containing electrons. So yes, we can see 1 and 2 shells are occupied. So this is correct. So we have 2 and 4 correct. Option D. Next, we have to complete a dot and cross. Ammonia NH3 is a covalent molecule. Which diagram shows the outer shell electron arrangement in a molecule of ammonia? First, we have to know the pairing, bond pairing. We know ammonia forms triple bond, so one single bond with hydrogen, another single bond with hydrogen, another single bond with hydrogen. Ammonia gives a total of 3 electrons and shares one from each hydrogen. So nitrogen is in group 5. Group 5, meaning it has 5 valence electrons. Valence means number of electrons in its outer shell. So if it shares 1, 2, 3, it should have a lone pair as well. 1, 2. And there is no lone pair with hydrogen. No lone pair with hydrogen, as hydrogen only contains one electron. So any option with hydrogen lone pair will be wrong right away, as they have hydrogen with lone pairs. Any option with zero lone pairs for nitrogen will also be wrong, giving us C as the correct, as we have a lone pair also, and total number of nitrogen electrons are 1, 2, 3, 4, 5, and total bonding is also like we decided over here. So first, if you get your theory together, the options won't confuse you. Don't right away dive into the options and look into them because they will confuse you. Maybe you just right after you see option A, you mark it correct because you see that, oh, triple bond is present. I mean, three single bonds are present. But if you go through all the options or you get your act together at first, you will know that the presence of a lone pair is also necessary. Next, which structure does silicon 4 oxide most closely resemble? Okay, so these structures are not given by the examiner itself. I pasted them from somewhere else to just show you the structures, just so you know these are not given by the examiner. So this is diamond, this is silicon oxide, and this is graphite. Graphite has layers of atoms which slide over each other, so they conduct electricity also, and it has a lone pair. It has free electrons, delocalized electrons as well. And here you have the structure of silicon oxide and oxygen. Both are tetrahedrally arranged. Just the difference is that it has silicon and oxygen, and diamond all carbon are present. So we know that silicon dioxide is giant, so no simple molecule will represent it. Sodium chloride is also giant, but it is an ionic compound, and it also does not fit the arrangement. So we have been left with diamond and graphite only. Graphite, as I told you, this is the arrangement. You should know this for all three. So diamond is the closest option. Substance P conducts electricity when solid. Only metals conduct electricity when solid. They do this because they have a free electrons, or they have mobile electrons, or delocalized electrons. Another substance which can conduct electricity is are ionic compounds only in molten or aqueous state, not in solid. And they do this because they have free ions, cations, and anions. Okay, so now everything is opened up for you. You can just select the answer. Anions, no. Cations, no. Because if it is conducting electricity while being a solid, it is clear that it is not a compound, not an ionic or covalent compound. It is a metal. So metals have delocalized movable electrons. So so three only. Option D. Next is which equation represents a chemical change? Chemical change, okay. So first is barium chloride. It's still barium chloride, just the state is changed from solid to liquid, which means it has melting. It has melted. So this is a physical change, not a chemical one. No reactive, no electrons transferred, nothing else. Here, as you can see, calcium reacts with sulfate, ion, radical, and there is a transfer of electron. Although the state is changed too, but the chemical change is evident. In any other option, there is no chemical change. In this too, it has only dissociated. This means it has been dissolved in water. Potassium chloride dissolved in water. And for D also, it's just ionization, sodium nitrate, the same substance, no new product is formed as it is still. It is no solid is produced, no new product is formed, it is still the same. So B is the final answer. Next, which sample contains the largest number of molecules? For number of molecules, we have formula moles equals to number of molecules over the 6 Avogadro's constant, which is 6.02 times 10 to the power 23. So first we have to calculate moles for this because we don't have the moles. So methane has MR 16. For moles, we will do N equals to G over MR. G is mass in grams. So number of moles for methane will be 16 over 16, which is 1. So number of molecules will also be equal to the Avogadro's constant itself, as it will be multiplied by the number of moles, which is 1. So this is for methane. Now, any substance having moles less than 1, it will have fewer molecules than methane, because eventually we know that for number of molecules we multiply the Avogadro's constant, we will multiply it by the number of moles. So the higher the number of moles, higher the number of total molecules. So if we just calculate the number of moles, we can know who has the which compound has the largest number of molecules. So for methane, we have 1 mole. For oxygen, we will have N equals to 16 over 32. 32 why? Because there are oxygen is diatomic, 2 oxygen atoms. One oxygen atom is 16, 2 oxygen atom will be 32. This will give us 0.5. Thus, 0.5 moles will give multiplied by the Avogadro's constant will give us a lower value. As for phosphorus has an atomic mass of 31. So 16 over 31, again it will be less than 1. Less than 1. As for 16 dm cube of methane, now this is interesting. Again, we will take out calculate mole 16 over 24. This will also give less than 1. 8 twos are 8, 3s are 24. 2 over 3 less than 1, obviously, because the numerator is smaller than the denominator. So we don't have to do all the working. We just have to calculate the moles, and the higher the number of moles, higher the number of molecules. So option A is correct. Next, the concentration of a sample of dilute aqueous sodium hydroxide is found by titration. The apparatus is shown. Simple titration is taking place. Which information is needed to calculate the concentration of the dilute aqueous sodium hydroxide in mole per dm cube? So you have to know this basically, and it is some common sense too. The unknown quantity over here is sodium hydroxide. So you don't know the concentration of NaOH. What you do know, however, the equation through which they both react. So you know the molar ratio, the ratios, the stoichiometric ratios, how many moles of HCl requires how many moles of sodium hydroxide. You know that. So for concentration, if you know the volume of NaOH you are taking and the number of moles can be taken out if we know the moles of HCl, and through the moles of HCl, if we calculate moles of NaOH from this and the volume of NaOH, we can get the concentration of NaOH. But for the moles of HCl, what do we need? We need again concentration and the volume of HCl both. Because if we don't have these two, we can't calculate the moles. So I hope this is clear. Concentration of HCl needed? Yes, it is needed. So A and B is correct. Why is it needed? For moles of HCl. For moles of HCl. Same as for this, for moles of HCl. Volume is also needed. So either option A or either option B or option D. But no, option D does not have volume, so no option D. Now, molar mass of HCl. This is not needed exactly because volume and concentration is enough. We do not need the molar mass or the MR. N is equals to CV, we can apply. We don't need the molar mass. And if we were using molar mass, we would need the mass in grams of HCl too, which we don't have because we do it through a burette, which measures volume only. And concentration is we know when we make the solution. So option B seems to be correct. Next, volume of NaOH used. Yes, we do need to know that. And molar mass of NaOH, again, there is no need for that. Next question. In experiment 1, aqueous copper to sulfate is electrolyzed using graphite electrodes. In experiment 2, aqueous copper to sulfate is electrolyzed using copper electrodes, which is not an inert electrode, it is an active electrode. Which statement identifies a half equation for a reaction at one of the electrodes? So, for electrolysis, you need to know the various electrolytes used and then the deposits on the anode and cathode while using active electrode like graphite or while using copper electrodes too. And then you need to know what happens to the solution itself, the composition, the observations, everything. So in experiment one, they're saying in option A, in experiment one, the half equation for the anode reaction is 4OH minus will give us two water molecules plus one molecule of oxygen and four oxygen. This in itself is factually correct. You should remember these half equations as well. Whenever oxygen is discharged, sorry, whenever the hydroxide ion is discharged on the anode, as it is an anion, it will go on the anode, yes. Now just what we have to confirm is the reactivity series, whether it is below copper to sulfate, what anion is present here, sulfate anion. So in the reactivity series, we have to check whether OH minus is below sulfate or not, because the compound, the substance which is below, easily discharges. It is more easier to discharge that substance, and in the competition, the substance which is lower will win. For example, if in a solution copper is also present and hydrogen are also present, hydrogen and copper both are present. So copper will discharge and hydrogen won't because in the reactivity series, hydrogen is above and copper is below. So copper easily gains back its lost electrons. Similarly, the OH minus ions loses the extra electrons in the water and the oxygen, all of it, because it is a radical. So this in itself is correct as sulfate is above OH minus in the reactivity series. You have to memorize this, the anion series, and mostly OH minus is at the below, and mostly you just know this that sulfate is not discharged, but OH minus is discharged. Option B, in experiment 1, the half equation for the cathode reaction is 2H plus 2E minus, which will give us hydrogen. Even if the equation is correct, it does not mean the option is correct because cathode, I just told you hydrogen won't discharge, copper will discharge. Next, in experiment 2, the half equation for the anode reaction is copper. This is in itself wrong because copper is a cation, it won't discharge at the anode. And similarly over here, it is an anion, it won't discharge at the cathode. So option A is the best option. Next, which substance is not produced during the electrolysis of concentrated aqueous sodium chloride? Okay, so aqueous, whenever there's aqueous, we involve water molecules as well, and it is concentrated. So we know that, and it is not produced. This means that either neither the substance produced is produced via reaction in the electrolyte solution, nor is it deposited on the electrodes. So what are the ions we have? Na plus, H plus, Cl minus, and OH minus. So Na never discharges. This is a rule. Na never discharges. Sodium and potassium never discharge. They're at the top of the reactivity series. They form very strong bonds, so they don't deposit on the electrodes. Hydrogen will discharge, yes, because it was competing with Na. Cl, although it is above hydroxide ion in the reactivity series, it still will discharge because concentrated is used. Whenever concentrated is used, the word concentrated is used, that substance is preferred. Next, OH minus, so we already decided Cl minus will deposit. So chlorine is produced, yes, from chloride ions, chlorine will be produced. This is not the half equation, this is just a demonstration of what will be produced. The half equation is different. So chlorine will be produced, yes, chlorine will be produced. So we want which is not produced. Hydrogen is produced, yes, hydrogen is discharging. Sodium is produced, no, sodium is not produced. Sodium is not produced. Potential option D, sodium hydroxide. Now, you might say that how can a compound deposit entirely on the electrode? But this is the point. The compound sodium hydroxide is not depositing on the electrode. Sodium hydroxide is produced via the reaction of Na plus OH minus in the electrolyte solution because OH is also not just discharging and Na is also not discharging. So it is produced. It is produced. Only sodium metal is not produced. Next. Methane burns in excess oxygen. The equation is shown. Bond energies are shown. What is the energy change for the reaction? First, it is smart to make all the bonds CH4 plus O double bond O, and on that side we have C double bond O and C double bond O plus O single bond H, O single bond H. We have to include these values as well, 2 and 2. CH4, CH we have 410 times 4. And by the way, enthalpy changes energy in minus energy out. Energy over this side minus the energy over this side. So 4 times 410 plus 2 times O double bond O is 496 minus, make sure you make the correct brackets. I'll bring this right over here. So C double bond O is 805 and we have two bonds. So 2 times 805 plus 2 times 460. Option A seems to be correct. No, it has 4 over here. Not correct. Or is it? It is correct. My mistake. Because we have two bonds over here. So 2 times 2 times the bond energy, 460. So 460 over here, 460 over here, and then the 2 outside. So this will give us 4 over here. This is correct. So this is a calculation based question. You don't need to look at all the options. Next, 12, which change increases the rate of reaction by decreasing the activation energy. So there are two conditions. Rate of reaction should also be increased and the activation and the substance should be doing it via decreasing the activation energy. So yes, addition of a catalyst by offering an alternate reaction pathway. Decrease in size of solid reactants. This is correct as it will increase the surface area, but it won't decrease the activation energy. So wrong. This is increase in concentration. This all of these increase the rate of reaction, but what they won't do is they won't decrease the activation energy. Sorry. Same is for temperature and same is for concentration. Next, in the contact process, sulfur dioxide is reacted with oxygen to form sulfur trioxide. Which conditions are used in this reaction? Standard question regarding the conditions, also present in P2, P4, sorry. So temperature is 450, we know, and pressure is 200 in contact process with catalyst vanadium 5 oxide. Iron is used in the Haber's process and 20,000 kPa is also used in the Haber's process while manufacturing ammonia. Next, which reaction is reversible? An iron nail rusting when left in moisture. Rusting is not reversible. Once rust is formed, you cannot reverse it. You cannot get the original iron back. Second, limestone reacting with an acid to form carbon dioxide gas. Limestone reacting with an acid to form carbon dioxide gas. Okay, so we will confirm this. Let's read all the options. Limestone is basically CaCO3 plus H2O. This is a plus, sorry, HCl, for example, any acid, CaCl2 plus CO2 plus H2O. This is what they're telling us basically, but this is a redox reaction, not a reversible reaction. Not a reversible reaction. We don't have any evidence to suggest this, nor we can make any assumptions in MCQ especially. Second, magnesium burning in air. This is combustion, and burning, producing a white ash means it has fully burned. D, white anhydrous copper sulfate turning blue when water is added. So when we add water, it becomes blue. This is also a test for water. So we can heat it again to remove the water and it will become white again. So it will become anhydrous again. So pretty reversible. Next, the equation for the reaction of sulfur dioxide with acidified potassium dichromate is shown. What is oxidized and what is the oxidizing agent? So what is oxidized? Meaning who has gained an oxygen or increase in oxidation state. And what is the oxidizing agent mean? What has reduced itself, what happened to it? Was it oxidized or was it reduced? So they told us it is the oxidizing agent, and the oxidizing agent oxidizes others and itself is reduced. Okay. So what is oxidized? This right here is sulfur dioxide, and on the other side we see an extra oxygen is added to it. So it is oxidized. Yes. As for the oxidizing agent, we have to see whether it has reduced or not. So we can see hydrogen itself was not reduced as it has gained oxygen. So hydrogen has oxidized. Moreover, it has zero charge over here, or I should say oxidation state, and over here plus one. So this leaves us with option A, because you can see Cr2O7 had 7 oxygen over here, and here it does not have any oxygen. So we first look at what happened to the oxygen, whether it gained an oxygen or lost an oxygen. Then we see the oxidation states. What is the definition of a strong acid? Pretty straightforward. You should know the definition. Strong acid is a proton donor which is completely dissociated. So option C. Proton acceptor is a base. This is an acid but partially means weak. Next, which statement about amphoteric oxides is correct? Amphoteric, you should know, Al2O3 and ZnO are two amphoteric oxides in your syllabus which react with both acids and bases. They exhibit both behaviors, acidic and basic both. Whereas the acidic oxide only react with bases and the basic oxides only react with acids. Because a substance with the same nature does not react with another substance of its same nature. For example, two metals won't react. Never. Never. Similarly, so over here they are made by combining an acidic oxide with a basic oxide. We don't know. They react with water to give a solution of pH 7. They don't react with water. They react with both acids and base. Textbook definition. They do not react with acids or bases. Incorrect. Next question. Copper 2 carbonate is formed when aqueous sodium carbonate is added to aqueous copper 2 nitrate. Okay, the ionic equation for the reaction is shown. How is pure copper 2 carbonate obtained from the reaction mixture? We know all carbonates are insoluble. All carbonates are insoluble, and moreover, they have indicated here with us S as well. So, if something is dissolved in a solution, obviously we have water in here because all substances are aqueous. So, if it is dissolved, we can't filter it directly, but this is insoluble. So what we will do, we'll filter first of all. Next, after filtering, we don't need to evaporate. Why would we need to evaporate when from the filter paper, when the solution is passed, the residue here collected is copper 2 carbonate. So filter, wash and dry. Wash the filter paper or the residue. Next, Q and R are elements in the same period, meaning in the same row like this. Q has 7 electrons in its outer shell and R has 2 electrons in its outer shell. This is very critical information. Which statement about Q and R is correct? So Q has 7 electrons in its outer shell, meaning it is in group 7. R has 2 electrons, meaning it is in group 2, which shows us this is a metal, this is a halogen, or you can say a non-metal. So Q is a metal and R is a non-metal. Complete opposite statement. Q and R have different number of electron shells. No, because they are in the same period, and period shows us number of shells, electron shells. R is found to the right of Q in the periodic table. No, we know group 2 is over here and group 7 is over here. So Q is found on the right of R, obviously. The proton number of R is less than the proton number of Q, obviously, because it has only 2 electrons. But this is not the primary reason. The reason is because they are in the same period, meaning they have the same number of electron shells. So the only difference there can be in their number of electrons or in their number of protons is indicated by these, by what we know. Or forget it. Let's discuss this. This D. The proton number of R is less than the proton number of Q. Proton number increases this way, increases. As you go along, the proton number increases. Here's the evidence. See for yourself. 3 for lithium, 4 for beryllium, and 5 for boron, 6 for carbon, 7 for nitrogen, 8 oxygen, 9 fluorine. So you can see it is increasing. So if we take a sample from group 7, we have fluorine over here. Fluorine has 9 proton number, and from the same period we have to take one element from group 2, which is beryllium. So it has a lesser proton number. So hence proved. The proton number of R is less than the proton number of Q. Next, lead 2 sulfate is an insoluble salt, which reaction produces a mixture from which lead 2 sulfate is obtained by filtration. So which reaction will produce something which has lead sulfate in it? So adding solid lead 2 carbonate to dilute sulfuric acid will give us lead sulfate plus carbon dioxide plus a soluble salt. Oh, sorry, plus water. And let's see all the options one by one. Whenever we choose to form a salt, an insoluble salt, it is better, it is obviously always preferred. This you should know beforehand. Always nitrates are preferred. For example, if we needed to obtain a chloride, or if we needed to obtain calcium sulfate, even then we would take calcium nitrate plus H2SO4. This we can't take because lead won't react. Lead 2 hydroxide, this will neutralize and other substance will be formed. So this we can't take. As for A, we don't want any extra substance to be formed. So we have to choose. This is not wrong exactly. This is not exactly wrong. But the thing is that we have to choose the best option, which is lead 2 nitrate. Nitrate because this is soluble in water. Which statement about alkali metals is correct? Lithium alkali metals are group 1 elements. You need to know their properties, their trend along the group. Lithium is more dense than sodium. No. We know density increases down the group. Melting in same is for melting points and boiling points. So sodium will be more dense than lithium. Or sorry, my bad. Density decreases because reactivity decreases down the group. This is not density, this is actually reactivity. Reactivity decreases along the group, down the group, and melting points and boiling points and density increase along the down the group. Increase. So lithium is at the top of the group one. We can see over here. So lithium can't be more dense than sodium. Moreover, next, sodium is more reactive than potassium. No, this is not possible because lithium is the most reactive metal in group 1. As down the group, reactivity will decrease. Next, sodium has a higher melting point than potassium. Yes, because as we go down, the melting point increases. They are in group 2 of the periodic table. No, they are not in group 2. We know. Alkali metals are in group 1. So, incorrect. 22. Which row describes the properties of a transition element? This should be on your fingertips, all the properties. They have a high melting point. Yes, they have a high density, of course, and they form colored compound. Yes, they have variable oxidation states. Which row identifies the properties of zinc? Zinc is a transition element, metal. So the thermal conductivity is good, yes, and it is not. It is more reactive than copper. So it is amongst the metals with react with dilute acid. Next, uses of metals depend on their properties. Which property is necessary for the use given? So metal metal is used in car bodies, yes, but not because it is ductile. Ductility is affiliated with wires. Cutlery conducts heat. No, we don't want the cutlery to conduct heat. Next, food containers resist corrosion. Yes, because food containers come in contact with water, and any metal uh, which is corrosive or which corrodes easily, it can wear off very easily. So this is correct. As for D, we have this is not correct. Overhead electrical cables because of a good conductor maybe or ductility maybe or lightweight or light density, less density. This is not correct. Next, which compounds both contribute to acid rain? We know oxides of nitrogen and oxides of sulfur, which is sulfur dioxide. So carbon monoxide, no, carbon monoxide is toxic. Carbon dioxide is causing global warming, greenhouse gas. Same over here. Oxides of nitrogen is correct, but carbon monoxide is wrong. C is correct. Oxides of nitrogen and sulfur dioxide. Again, carbon dioxide is coming, which we don't want. Next is P, Q, R, and S are metals. Q reacts violently with water. P reacts with dilute HCl, forming hydrogen. Q reacts violently with water, so this is pretty reactive, or we should say most reactive from the list we have because violent reaction with water. You have to maybe you have to remember and yes, you should know the reactivity series itself and the extraction of metals depending on the reactivity, their reaction, vigorous, slow, vigorous with hot, slow with cold, every reaction with there should be a table which should you should remember. R reacts with water to give hydrogen. This is less reactive than this. S is formed by heating its oxide with carbon, which means it is not that difficult to extract it out because the most difficult to extract are the which are the elements or are the metals which are at the top of the reactivity series because they can only be separated through electrolysis. This is thermal decomposition. Okay, so Q is the most reactive. We know this. So the option we choose, Q should be the most reactive amongst all four. You have to work smart with the MCQs. Even if you don't know the absolutely the table you haven't got it in your on your fingertips, even if you don't know it very well, you can still guess the answer by being a little smart. So you should know this much, and it is obvious violently with water. So the thing is, if you choose A, Q should be the most reactive amongst all four, which we say which it isn't, because the reactivity series says that potassium comes before sodium. So this is not correct. As for this has magnesium over here, which is less reactive than calcium. So this is not correct. As for C, this is a potential answer because sodium is more reactive than all of these. So C or D, because D also has potassium over here. Next is that S is formed by heating its oxide with carbon. So we can see this, and R reacts with water to give hydrogen. And what does Q do? Q reacts violently with water, so okay. And P reacts with dilute HCl, forming hydrogen. Okay, so C and D both are potential answers. You can be tricked over here if you don't know this, that what is extracted by which method. Because magnesium is separated by electrolytic reduction. So it turns out that you can't guess the answer. They're too smart. If you don't know the information. Zinc, however, is heated with carbon to separate it. Next, which compound is formed when iron rusts? Anhydrous is straight away wrong because iron rusts in the presence of water. Next is hydrated iron 3 hydroxide. Hydrated part is correct, but hydroxide is not formed, oxide is formed. This is fact. There's no explanation to it. Why is cleolite? This is also a fact, used in the extraction of aluminum by electrolysis. So it dissolves the aluminum oxide. Okay. It protects the anodes from corrosion. No, this is no such thing. It changes bauxite to aluminum oxide. No, bauxite contains aluminum oxide. It decreases the melting point of the aluminum. This is where you will go wrong because it does not decrease the melting point of the aluminum. Rather, it decreases the melting point of aluminum oxide. The metal is not yet extracted. So this is definitely wrong. So this leaves us with A because aluminum oxide is dissolved in cryolite, which is there to reduce its melting point. Next, a wax candle is made from a mixture of hydrocarbons. The candle is lit and placed in a gas jar along with a strip of cobalt 2 chloride test paper as shown. Okay, you can see the figure over here. After a short time, the oxygen in the jar is used up and the candle flame goes out. Oxygen is used up, so and carbon dioxide is produced because combustion always carbon dioxide is produced, which is a gas, and water is produced also, and oxygen is used up in the while combustion takes place. Candle flame goes out because all the oxygen is used up. Which substance does the cobalt 2 chloride paper identify? If you remember, we just did an MCQ involving cobalt 2 chloride, or was it copper 2 sulfate? Yeah, it was copper. So this is a fact. Even if this all of this wasn't given, you know that water is used or cobalt water is tested by cobalt 2 chloride. You observe a color change when you test cobalt 2 chloride with water, or the other way around when you test water with cobalt 2 chloride. So of course it is water. Carbon dioxide is produced, but it does not test for carbon dioxide. Carbon monoxide may be produced if the oxygen is in lesser amount, but still it does not test. Sulfur dioxide can be produced because hydrocarbons, but still the thing is what is cobalt 2 chloride identifying, which is water. Now, organic chemistry is starting over from here. The hydrocarbon C4H8, you know, this is butene has two structural isomers, but1-ene and but2-ene, okay? Which statement is correct? But2-ene has a structural formula CH3CH3 and the same general formula as butane. No. General formula is same in a homologous series, which we have as alkenes, alcohols, carboxylic acids, and polymers, as we have. Polymers might not be a homologous series, but they're a class of organic compounds we study. So butane is an alkane. Butane is an alkane, so it has a different general formula. But2-ene is an alkene. So option A is wrong. Option B, but2-ene has a structural formula. This we can see there are four carbons. All bonds are occupied. The formula is correct. And the same empirical formula as ethene. So but2-ene formula will be C4H8 and ethene will be C2H4. So the formula will turn out empirical formula is the simplest whole number ratio of the compounds. So two ones are two twos are. This will give you CH2. This will be C4 ones are four twos are CH2. So correct. This is you can be absolutely sure with this if you draw the correct formula. Now you might get confused with option D, but the thing is that the bonds are not complete here. If you see, all this is correct, but CH doesn't have its bond, or I might show you CH3, CH, okay, and CH2 and CH not quite turning out well, yeah. CH over here, CH, not even CH2. So here the bond is lacking, over here the bond is lacking, so incorrect formula. You might go wrong with this one, but read the question carefully and do all what it is telling you to do. Which compound rapidly decolorizes aqueous bromine? This is the test for alkenes, or you might even say unsaturated hydrocarbons because they contain a double bond, carbon-carbon double bond. So propene, as all other are alkane, acid, alcohol, and this is alkene, our correct answer. Next, what are the products of the addition reactions of ethene with bromine and hydrogen? So ethene has this structure. When it reacts with bromine, one bromine comes over here on one double bond, one bromine comes over here on the other double bond. Why this happens when the bond breaks? This is why it is addition reaction. So the structure will be CH, H, CH, Br. So this is correct. This is not correct. Or this is the same exactly. Sorry. This is the same. It's incorrect because of this. We will see. This, however, is not correct because it only has one Br. There should be two Brs. Same is for this. Now, for hydrogen, what will happen is if you have a structure like this, see again, it's the same structure basically, and you are reacting with hydrogen. So the same thing will happen. The double bond will break again. The double bond will break again, and one hydrogen over here, giving you CH3, and another CH3. Okay, what is wrong over here? This is again an alkene. This is the same compound, CH ethene. So this is wrong. Only option A is correct. Next, ethanol is manufactured by fermentation, yes, and the catalytic addition of steam to ethene, yes. Fermentation in which yeast acts on glucose anaerobic respiration takes place and alcohol is formed. Ethanol specifically over here, which row describes an advantage of both methods. So it should be an advantage of both methods. It it being factually correct is not enough. It should be an advantage too. Ethanol needs to be purified. Well, this is not an advantage. The process is continuous. Yes, this is an advantage, but this is not. It is a batch process. Ethene comes from petroleum. Absolutely no link with it. Advantage. The process is slow. This is a disadvantage. The process is rapid. Okay, but not an advantage. Oh, sorry. This is an advantage, but we are limited by this. Next is renewable resources are used. Okay, the ethanol produced is pure. Well, yes, it is pure. Ethanol needs to be purified with fermentation, but this was a disadvantage. This is pure. So option D. Methanoic acid and propan 1 all react to form an ester. What is the structural formula of the ester? First of all, we need to count the total carbon atoms which the ester will contain. Three from here because of the prop we know, and one from here. So four total carbons. One, two, three, four. 1, 2, 3, 4. 1, 2, 3, 4. Turns out everybody has four carbons. Okay. So the functional group will be COOO. We know this because, or maybe I should draw the entire structure for you to better understand it. Now look, methanoic acid is CH COOH and one H over here. Plus propan 1 all CCCHHOH and two more H. So this is propanol and this is the acid. So what happens is we know the standard, this goes away. The compound is joined like this, COOO, and rest is the same. So the structural formula, if we write it, HCOO, CH2, CH2, CH3. So whatever follows this in the options, that is the correct answer. So as it turns out, it is option A. We don't have to look much further. The problem with this, I can tell at first glance, it contains COOH, which is carboxylic acid functional group. So this cannot be ester. As for this, if we draw this out, this is COOO, COCH3. The problem is where the double bond with oxygen is present, that is the acid. We know this. We should know this. And we want acid to be methanoic, one carbon. It has two carbons, so wrong. This is a problem with this. Option B has, again, it has even worse. It has three carbons for the acid, again tricking you, trying to trick you, and one carbon with the alcohol. Now, how do we know what is the alcohol and what is the acid? We know with the double bond of oxygen. After the double bond of oxygen, another O comes, and after that, whatever comes is an alcohol. And just don't keep in mind the before and after, just keep in mind this double bond. Whatever is this chain is an acid, like this, like this. Okay, so only option A is correct. And if we were to name it, it would be metha propyl methanoate. Propyl for alcohol, we write the name for alcohol first, and this is for the acid. Next, what is the correct structure of PET? So, if you know the monomers, you can easily spot out the correct structure. PET has two monomers. One contains the acid dioic acid, two acid functional groups, One is this. The other monomer is diol for PET. Diol because alcohol functional group on both sides. Now, you might confuse this with nylon because nylon has the nitrogen, the amine group for one monomer and the acid group on one monomer. Both are formed through esterification or condensation, you can say, because this and this goes away just like we did in the last question. So you have to see this. You have what do you have to look for? Because if I show you how they join, they will join like this. If we continue this C on, this will be like this. Just make the two molecules and just remove the H from the alcohol and OH from the acid. So this will join with the O of the alcohol, which will then join to its carbon chain, which will then join to another O, which will continue on further. Okay, so two carbons on either side, one carbon on either side, and one oxygen on either side. Carbon should have a double bond. So option A is straight away incorrect. Where did this nitrogen come from? Option B seems to be correct as yes, this is present. Oxygen is present like the way it should be. Okay, so yes, let's look at other options. Another amine. They know you will confuse this with nylon. That's why they're giving you this. Next, now you can be mistaken by this. This is this looks like this, but the difference is here. This is not a repeat unit of this. We should have a repeat unit of this. Once we complete the molecule, the remaining should be exactly the same. It should be repeating. The repeat unit suggests, the name suggests that it should be repeating. So this should have been replicated over here again, but which is followed in B but not in D because here we have an O with the carbon chain and a carbon with the carbon chain. So this is not right. We only have two kind of monomers, one with acid on both sides, one with alcohol on both sides. The one with two different functional groups on one monomer is protein. But over here, you just have to know this for this MCQ. Alkanes undergo substitution reaction in the presence of UV light. Which equation represents a substitution reaction of ethane? C2H6, okay, ethane, this is plus Cl2, yes, equals to C2H4. Now the thing is, two hydrogens at once are gone from H4 and no Cl is attached. No Cl. What was the substitution for? There was no halogen alkane formed, so wrong. Next is C2H6 plus Cl2. Yes, one Cl comes, one H is gone, so this is correct. Plus HCl, the H which went away combined with the one Cl that remained. So yes, this is correct. The problem with this is no HCl is formed and plus the this is not correct because two Cl don't combine at once. This occurs in stages. Okay, and in this HCl is reacting, which we don't want. We want Cl2. Methane reacts with chlorine in substitution reactions. How many different products containing a single carbon atom can be made during the reaction? So methane contains four hydrogen, one carbon. CH4 is the formula. CnH2n plus 2 is the general formula. So once we do substitution, Cl comes. So this will become this. We do this again, another Cl comes because we can do it endlessly. Another Cl comes, two hydrogen remains. So how many products are there? One, two. After that, another Cl comes. So you get the point, right? Another Cl, another Cl. So if we were to name it, this would be chloro, chloromethane. This would be dichloromethane. I'm going into absolute details because organic many students find it really hard. Trichloromethane because of the three chlorines, tetra because of the four chlorine, chloromethane. Okay, so four different products can be formed. Beyond this, we cannot go because there are no further hydrogen atoms. So option C is correct. 38. Rock salt is a mixture of salt and sand. They have told us the method used to separate the sand from the salt is listed. Crush the rock salt, okay. Add to warm water and stir to make a solution in which salt will dissolve while sand will remain suspended or settle at the bottom but won't dissolve. Sand is insoluble. Pour the mixture through a filter paper. So the filter paper will catch all the sand as residue. Evaporate the water to crystallize the salt. Okay. The filtrate in step 2 is pure water. They're saying when we remove the water through this containing sand plus salt, this what we get here is pure water, distilled water. This is not true because only sand goes over here. Only sand is over here. Salt plus water solution is still over here, so not pure. The residue in step 2 is pure crystals of salt. No, the residue is the one present over here. Salt won't be separated by filter paper. We know. The solute is salt. The solute is salt. Okay, yes. The solute is the substance which is being dissolved. The solvent is the solution or the medium of where the is the water basically. Water is the solvent and salt is the solute, the substance we dissolved and in which we dissolved, it is the solvent water. The solvent is a mixture of salt and water. No, the solvent is water. And yes, water. Two compounds M and N are dissolved in water and separated by chromatography. The results are shown. What is the RF value of M and which compound is most soluble in water? Okay, so this is the solvent front, meaning the water or the solvent, whatever it was. So one more thing before starting it out. Solvent front, you can guess this MCQ from this also. Just a smart tip. Okay, so RF value is the distance traveled by solute over distance by solvent. They knew you would confuse these two and swap these values. That's why they gave you both. Because if you divide 2 by 10, which is the correct formula, you will get 0.2. But if you divide 10 by 2, which is the other way around, you will get 5, making a mistake. Okay, so distance traveled by solute upon distance traveled by solvent is the RF value, the retention factor. The retention factor means how much the solvent retained the substance M and N. So the further it traveled, it means the more soluble it is. So N is more soluble than M. This is for sure. So either B or C, D. Then we know the RF value is 0.2. The retention factor for M is 0.2 and the most soluble compound is N. So these are two different things they are asking. They are not asking RF value of N. They are asking RF value of M and soluble most is the one who travels more. Next, when acid is added to salt X, a gas is produced which turns lime water milky, which means it contains carbonate ions because this gas is carbon dioxide gas. And whenever an acid reacts with carbonate containing salt, it releases carbonate. When sodium hydroxide base is added to salt X, a gas is produced which turns litmus paper blue, which means ammonia is released. This indicates that it contained ammonium ions in the salt. These are the both same salts. So this means that the cation should be NH4 and the anion should be carbonate. Both should be present because both gases are being released. So the only option we have is B. This has calcium, this has nitrate, This has carbonate but does not have ammonium. So option B. So we have completed the paper. Thank you. Jazakallah khair.